Okay, sorry I was interrupted in the middle of that video. So we're starting, this is going to be part 2 of my video for the second half of 6-5. So this is all practicing, all mixed up together. So this, notice, is a difference of squares. It factors into x plus 3 times x minus 3. This is also a difference of squares that factors into x plus 1 times x minus 1. Look at that. So each one of these factors factored even further. Speaking of difference of squares, let's look at I. There's no GCF. It's a difference. It's either got to be a difference of squares or a difference of cubes. This is definitely a difference of squares. So it factors into 6x cubed, because the square root of x to the 6th is x cubed, plus 7, and 6x cubed minus 7. And those are both prime, which means we are done. Moving on to J. Is there a GCF? Absolutely. We can take out a 2x squared. Don't forget, you should always do that first. Dividing it back in, that gives me x squared plus 2. Does this factor any further? It doesn't. It's a binomial, so it would have to have been a difference of squares, or a difference of cubes, or a sum of cubes, of which it's neither nor. So sometimes that's all you can do is take out a GCF. Be happy about it. It's less work. I can GCF out of here. I can take out a 3xy, which will leave me with just an x minus 5y. And again, that doesn't factor any further. So there's another one where all you could do was take out the greatest common factor. Well, how about L? Does it have a GCF? It does not. There are two terms. It's a difference. It's either a difference of squares or a difference of cubes. Well, this right here shall tell you it's a difference of squares. What's the rule? X plus the square root of 64, which is 8, and x minus 8. How about M? There's no GCF. Can I factor it? Is it a difference of 2 squares? It is not. It's a sum. This one is prime as it stands. There's nothing we can do to it. All right, let's keep going. GCF here, it looks like it's a 2x, which leaves me with x to the 4th minus 16. So again, we have a binomial. It looks to me like it's a difference of squares. It certainly isn't a difference of cubes. So again, what's the rule for difference of squares? It's x squared plus 4 times x squared minus 4. It's the square root of this plus the square root of this, and then minus. Oh, but wait, you're not done. One of those factors further. Which one is it? Well, it's not this one. It is this one. This is also a difference of 2 squares. So how do I factor this? It is the square root plus the square root times the square root minus the square root. That took 3 steps to factor it. That was huge. Can you now see why I fell in love with factoring when I was a freshman in high school? It's so much fun. Oh, is there a GCF? No, there's not. There are 3 terms. Immediately, we're going to backwards FOIL. This one's going to be a little bit easier because there's a 1 there, so it's going to be x and x. And then what multiplies together to get -6, but adds together to get -1. Think about it. Well, that's going to be -3 and +2. If you haven't stopped it and gone on and then come back to check. Maybe stop now, at least do the last 3 and then come back and check to make sure that you're okay. So for P, the first thing we're going to do is take out a GCF of 3x. So that's going to give me x to the 6th minus 9. 2 terms. It's either a difference of squares or a difference of cubes. Well, I can only take the square root of 9, so here we go. 3x times, and it's going to be x cubed plus 3 times x cubed minus 3. Now, neither of those factor any further because they're not, 3 is not a cube or it's not a perfect square. Now, when you do Q, so the first thing you have to look at again is there a greatest common factor for everything? No, there's not. You know that there's more than 3 terms, so you have to do grouping. So you might think, well, I'm going to group immediately 2 and 2, but if you look carefully, can I factor a GCF out of this first group of 2? I cannot. So I better think about reordering it. So again, there'll be numerous ways that you can reorder. I think I'm just going to go with the 5b squared next after the b cubed and the minus 9b minus 45. I'm just going to put them in descending order of the variable. But again, there are other ways to do it and get the same answer. So now when I group them 2 and 2, I can take a greatest common factor out of here. And what is it? It is a b squared, which will leave me with b plus 5. What can I take out of my second group, knowing that I need 2 positives when I do? Well, I'm going to end up having to take out a negative 9, which when I divide it back will give me positive b plus 5, exactly what I needed. So we're doing the grouping method. There's 2 big terms. They have the b plus 5 in common. When those are gone, what do I have left? I have b squared minus 9. Are we done? Look carefully at this. Do you see where that factors, again, as a difference of 2 squares? And how do you factor a difference of 2 squares? It's the square root plus the square root times the square root, oopsie, minus the square root. And there we go. And finally, R. I think we've used quite a lot of the alphabet here. So let's do R. So the first thing you should notice is there is a GCF. It's an x, which gives me x squared minus 4x plus 4. Now, although you don't have to, you could check and you would be able to see that this is a perfect square. But let's say you didn't see that, which probably in many cases you didn't. You can still go ahead and go old school and just factor it as a trinomial. We'll have x and x. And now what 2 numbers multiply together to get positive 4, but add together to get negative 4? Well, that's negative 2 and negative 2. What I would ask you to do, though, is it's okay that you didn't notice it was a perfect square at the beginning, but if at the end you see that you get the exact same 2 binomials, please write it as a perfect square of x minus 2 quantity squared. All right, and now you've had plenty of practice with factoring. Let's go on and now let's take it one step further and solve equations by factoring.